Today we are going to look into time series analysis using darts package. This is a recent package, but this has a very good potential in terms of usefulness for time series analysis. This could be like sklearn for machine learning. Darts could be the same for time series analysis. So before we go into this package, let's look into various analysis that we have looked in the past video. So this was analysis that from the past video. Let's recap it and try to do same functions in Dart. So we looked at airlines passengers data and try to do time series analysis. We use stats models package to do ETS decomposition, smoothing functions like Holes method, winter Holes method, ARIMA, SARIMA, SARIMAX, and FB profit, neural profit, and LSTM model, as well as XGBoost. So all of these functions we can implement using darts. So let's look into darts package implementation. So why darts? So darts is supposed to be all-encompassing time series analysis. When we say all-encompassing, discovery, ETS decompositions, visualizations, and pre-processing in terms of missing value, fillings, normalization, scaling, and everything within the same darts package. So we don't have to go and look into other packages. And all of these are various forecasting methods, including deep learning methods, and statistical methods, as well as machine learning methods. So if we look into evaluation, there are many methods to do evaluations as well. So there are metrics already defined within this package. There is also parameters search methods like grid search. So it is supposed to be covering all aspects of time series analysis. So far the implementation looks very good. The only issue that I have with this one is the if we do conda install or pip install darts package, it's not straightforward for you to install this one. I had M1 Mac and I couldn't install it really well. There were always some packages that were missing, and if you try to install them, it was causing further problems. So apart from that, I think for M1, Mac M1, and Windows, it's still they need to do some work. But on Linux machines, I think it works very well. So let's go back to our darts coding. Again, the objective here is to understand few methods and how to implement these. I'm not going in depth in terms of the parameters that can be used or the methods that are available here, the details of the methods. So wherever possible, I'll show you some references, but this is mostly to get started. You can probably get some data set and then try to implement the package that we had there here. So let's look at the outline of this darts package series. We have configuration, data functions, and in dart introduction, where I'll specifically talk about time series or object, and there are dart methods for doing forecasting, such as exponential, smoothing, auto ARIMA, NBeats model, which is a deep neural network model, and profit, and there are other statistical methods and machine learning methods. So one reason I'm using Google Colab rather than Jupyter Notebook, as I did before, was because of the implementation issues, especially if you try to use either pip install or conda install. There are some packages such as LightGBM, they are not compatible with either existing ones, or you have to do a little bit of workaround or spend some time installing it the right way. So in Google Colab, I was able to do it fairly easily. So that's the reason I deviated from using Jupyter Notebook from my local machine. So the first step is to install and mount a particular folder from my drive. So this is specific to this particular code is specific to Google, using Google Colab. Later, I created my folder structure has a data folder, notebooks folder, and images folder, and the project folder is specified in this format. If I have any utility files and I would want to use them, like such as import utils file, I can do that by including this code. So you just add this module path to wherever. Here I'll have utility file in this folder, and I'm adding that to the system path. So, and then data function. So we are going to work with airlines dataset. If you don't remember it, so the airline dataset contains two columns. The first one is the month column, and the second one is the number of passengers in thousands, and it goes, the date starts from 1949 January to 1960 December. So number of records is about 144. It's a small data set, but we can use it to do time series analysis. It's like a toy example for time series analysis. Okay, so here I do two functions. One is to get airlines data. All I'm doing is reading this airlines passenger CSV, and then I'm making this airline at month as a index column, and then the next column is the number of passengers. So train test, I'm splitting 1956. Remember, if you are using lock, this is also included within your range. So that is something that needs to be remembered. This particular date is also included. So if you look at if you plot the data, it will look something like this. There is a trend as well as a season. Looks like the number of passenger increases within a season. So that's why this data has both a trend and seasonality. So, and a good toy example for time series analysis. So if you want to get train and test data, for example, I can just call train test data. If you're evaluating many functions, this particular format or this particular way of calling data sets is quite useful. So this is the index column, and this is the number of passengers. So before going into Dart's implementation, let's look at one important object known as time series. This is a time series is a multi-dimensional array. So as you can see, when I try to print, if you want to convert a data frame into time series, you can call from data frame and train df, and you get this train time series. And I also did the same thing for test time series. So if you look into the details of the time series, you can see it's a multi-dimensional array. In this case, 3-dimensional array. So this is a month is the 96. This is the index, which is the first component, and then the second one is a call component. It is essentially one value, which is the value that you see here, number of passengers, and sample is just itself. So again, if we go down here, it's a better description. So the month is in date time format, and then the component is number of passengers, and the dimension with that coordinate is sample. So this sample is often useful. Let's say you do forecast, and maybe you do it 100 times, though the samples, there will be 100 samples, and all of those samples will be stored in this one, so that you can compute some confidence intervals around your estimate. So let's go to so here, if you want to know what are all the methods that are available in Dart's models, so I listed out using this function called list dir fm. So fm is dart model, so it shows all of the models that we have used before. At least most of the models: ARIMA, auto ARIMA, Theta. There are linear regression, ensemble models, NBeats models, Prophet. So we are going to look at few of these, but these are all the methods that can be used to do time series forecasting. So we will start with if you want to understand any of the method, you can just say help dot models dot theta, and it will list a, a, a big description of what the parameters are involved and the references and so on. So dot methods will start with exponential smoothing. So here I'm getting a train test dataset, and then I'm also I'm converting them into time series object, and it's using exponential smoothing from darts function is as simple as writing these 3 lines of code. So you have model exponential smoothing, and then fit train test, and then predict is you're predicting or forecasting for the length of the time series of test dataset. So once I have predictions, simply plotting or plotting prediction time series dot plot, test time series plot, and train time series dot plot. So you can see here the results, and I'm printing 3 evaluation metrics: MAPE, RMSE, and SMAPE, and all these functions are within data darts.metrics. So you don't have to go outside of darts to get metrics, right? So I'm printing here MAPE, RMSE, and SMAPE. You can see the MAPE is pretty decent, and SMAPE is also very good. So also from the plot you can see that for at least the initial 3 years it's doing a good job, but the last year seems like it's underperforming. It's not able to capture the trend. Probably something needs to be changed, but definitely it's a good prediction when you look at the MAPE value. So if you want to have a confidence interval around your estimate, all you have to do is you calculate number of samples, use a parameter called number of samples. That way it will estimate 100 times, and then you'll get a confidence interval around your estimate. So you can see this sample column is not filled, it's with 100 values, and then this component is what your predictions, and this is the number of months that you're predicting. So that index, which is the time date time index, is actually 48 values. So once you have those values, you can actually plot, and you can now have confidence interval here. So now let's look at auto ARIMA. So like what we did before, this is getting the data and converting them into time series, and then the model itself is just these 3 lines: model ARIMA, auto ARIMA, and then I'm fitting the training data set, and then forecasting to the length of the test data set. Once I have those 3 values, I'm plotting them again. As you can see, a MAPE is actually, when compared to the previous exponential smoothing, this is like 18 and that was 5, so it's not doing that great job. And also from the image you can see that it's a flat line, it's not doing a good job at all. Again, I all these metrics are from within darts. So if you go to NBeats model, this is a neural networks implementation, a deep neural network implementation, and this has very good performance in M3 M4 series competition, time series competition. So if you want to know the details, there is a paper here, NBeats Oreskins 2020, and if you understand ResNets, I think it's easy. It's probably easy to understand what these blocks and stacks are. But it's a fairly, they have 2 kinds of implementations. One is where you can explain the model, and the other one is like a black box model, and both perform well. So you can try this model, and if you want to understand, you can read this paper. Also, if you want to implement it, you need to know what block means, what stack means, and so on. So you have to read this paper and get some insight into what values should be used. But I have a simple example here. where I'm giving input length. It's using 24 values to predict next 12 values, and I'm using a number of epochs to be 10. Ideally you could have as big as 30 or even more. uh, um, Apart from these parameters, these three lines are very similar to what I used before, and the plotting is also same. As you can see, it didn't really do a good job. I think that linear trend is continuing. Maybe you need to try out different input chunk lengths and output chunk lengths and try to plot it out. But the map is, if you have really large data sets, perhaps this method is more suitable, deep neural networks model. But for this particular data set, it's not doing that great job, but at least it's following the trend. Did not capture the seasonality that well. So profit, we are already looked in the previous video. It's the same implementation but through dots. So I'm calling dots.model import profit, not from profit but Facebook profit, but from dots.model. Same implementation. I think they have a wrapper around it, and I'm calling it similarly as I did before. And these three lines are very similar in every aspect that we have looked in the previously. So again, I'm forecasting for length of time series, and you can see profit is doing relatively well compared to the previous method, but not as good as exponential smoothing. So the MAP is 9.4, SMAP is 9.075. So this is another implementation called a Theta, and here I'm showing how to do a grid search. It's a simple coding. So you are creating bunch of Theta values between actually about 50 Theta values. That's my parameter space. I'm trying to estimate the best parameter where I can do the forecasting well. So I'm iterating through all of these Theta values, and I'm calling the same three lines: model, and then model.fit, and then model.predict. So wherever the predictions are good, I'm computing MAP, and then wherever the predictions are good, I'm noting down the Theta value. Once I have best Theta value, I'm computing forecasting to the length of the test time series. This code is very similar to as before. So using this parameter estimation, you can see now your MAP is 4.454 and SMAP is 4.3, and RMSE is also very good. So you can see from the plot as well, it's a very good fit. You can also use machine learning methods such as regression models. You can call model is equal to regression models, and this is where you are using which of the sklearns method you want to use to do forecasting. This is the machine learning method, right? So in this case, it's doing a decent job. The 7.749, SMAP is 7.359, and so on. So also from the fit, you can see it's doing a decent fit. I remember I did not do any parameter tuning. It is already doing a good job. You can also change this model to like a random forest regressor, and you'll have a different machine learning method underlying this regression model to do forecasting. Of course, it did not do a good job as it before, so mostly it's trying to predict nearer values better, but farther values are not so good. So the MAP is not as good as exponential smoothing or even this Bayesian ridge regression. So if you want to evaluate several methods at once, just to see on ballpark which method actually does good on your data set, you can write a simple function like evaluation model, and then you can say evaluate each of these. You can simply call exponential smoothing, ARIMA, Theta, TBAT, and so on. And here you're calling the three lines. The model is already the first line, model.fit second line, and then model.predict is the third line. And then you can compute metrics and print them, and to know for yourself which model is performing better. As you can see, exponential smoothing is performing very well. So this is just an introduction on how to code, but if you want to know in depth, there's a good documentation. So there's a user guide, API references and examples, and also a quick start. You can look at the documentation here. Another utility is fill missing values. This one is quite useful. If your input data set has some missing values, you can simply use this function to fill in those gaps. And there's not a lot of extensive coding required. You call this function and it will fill the data for you. So yeah, as I said, darts is all encompassing time series analysis package. Hopefully if they continue to do the same development as they have done so far, it can become uh, what sklearn is for machine learning, and darts can be for time series analysis. So with that, I conclude this video.